Good morning, ladies and gentlemen. I welcome you to the International Renewable Energy Storage Conference, IRES. And the title of my speech will be Storage Solutions for Smart Cities, Interlinking Electricity, Heat and Gas Infrastructure. Instead of a conventional content overview, I would like to give you 3 hypotheses that need either to be proven or to be neglected. First, energy storage is cheaper than energy transmission. That might be surprising because quite often it's named that transmission is the cheaper solution instead of storing energy. The second one is not a really serious hypothesis. That is, experts from electricity sector destroy filling gas infrastructure. And the third one is, thanks to lignite, North Rhine-Westphalia is energy state number 1, and this will last forever. Normally, the discussion on energy storage is very focused on electricity sector. But first, we try to open the view to other sectors. And first, we look to the mobility sector. And in mobility sector, energy storage is a very common thing. Or could you think that all the cars are connected to a grid, that every of those hundreds of million cars around the world has a cable connected to the car? That might be a big confusion, especially in such crossroads, when every car is connected with a cable. So here in the mobility sector, energy storage is very normal. Even it's not a battery nowadays, but it's more a tank like this, just a box where we fill gasoline or diesel. Or in the case of gas-driven cars, it's then gas bottles like we see here in the right picture. Also in the heating sector, energy storage is a quite normal thing, even when the heat supply is grid connected. So this picture shows a quite typical boiler room with the boiler itself, and next to it we have in every house a heat storage device, normally a hot water tank. That is not really a necessity from a technical point of view. It also could be solved by just building bigger boilers, but it seems to be a positive impact having a storage here, a positive impact for the economic system of this building. Quite normal is having heat storages in a solar thermal heating system. That's a typical application of storages because we also would like to have hot water during night when the sun is not shining. So we store the heat coming from the roof here in the hot water tanks in order to have water in the night. But quite surprising is that we also have in buildings that are connected to the district heating grid, we also have heat storages there. Although the heat is coming via a grid infrastructure. Also here it seems to have a positive impact in the overall system implementing here energy storages. And also in the gas sector, it's very normal and used to have gas storages. In former times it had been gasometers like the one here in these pictures. Nowadays they are not anymore in operation. Now they made swimming pools out of it or producing TV shows inside such gasometers. Nowadays we need storage volumes much bigger than that, and therefore we have these underground caverns, salt caverns, where we can store much bigger amounts of natural gas. And there we have storages, although we have natural gas pipelines crossing all our country. So also here it seems to be quite normal to have energy storages. So energy storage is a quite normal device, but not in the electricity system. Why is that like that? I implemented here some parameters, and in the parameter here on the horizontal one, we have a logarithmic scale, and it displays the cost of 1 kilowatt hour discharge from a storage that is put into relation to the transmission cost. And the transmission cost is given in euro per meter transmission line and per megawatt transmitted. And we look at this parameter, We see the electricity sector is at the utmost right corner. It has an indicator of something between 20 and 100. Looking to the gas sector, it's already much cheaper. It's between 1 and 10. And when going to the heating sector, it's even getting much more cheaper. Then it's just 0.01 to 0.1. Doing that for the mobility sector does not really make sense, as mobility is not transmitted. So when we look to the first hypothesis to be proven, energy storage is cheaper than energy transmission, we not really can answer that question if it's right or wrong, because storage and transmission cannot be really compared to each other. But in relation between storage cost and transmission cost, in most energy sectors, those costs are extremely low. Only in the electricity sector, we have some problems in the system that either could be solved by storage or by new transmission lines. And in this case, quite often transmission is the cheaper solution. So energy storage in general is not a luxury solution, but it's just a run-of-the-mill product, except in the electricity sector. And so also coming to the second conclusion, experts from the electricity sector destroy filling station infrastructure. Always the experts from electricity sector think it's always the best thing coupling everything to the grid, solving problems by extension of grids. Sectors or experts from sectors of other sectors don't think so. And therefore in internet you find a lot of pictures like that where cars have something like a grid connection, or they have still left here apart from the filling station in their car. And in this example, somebody has written, yes, it is a woman. I'm quite convinced it was not a woman. It must have been an expert from the electricity sector, believing that he also needs to connect his car to the grid. And there are quite a lot of electricity experts that you find here in the internet. And even in some countries, you see it might be even forbidden to connect cars to the grid, as the police is involved in this situation. I implemented a second indicator, and that again is the cost of a kilowatt hour discharged from a storage unit, and then putting in relation to the generation capacity cost in euro per kilowatt. And again, what we see, electricity is in the utmost right upper corner. So it is expensive in terms of transmission and also in terms of generation. The gas sector, gas is not really generated, so we don't, or we leave it like that. And when we do that with heating, so the cost for electricity was a factor of 10 to 100. When we do the same for heating, it is just 0.001. And when we do the same for our cars, put the relation of a tank into the cost of the motor, we have such small values here that I even cannot name those numbers anymore. So we see electricity storage is expensive, yes, or we can express it also in a more positive way. Production and transmission of electrical energy is cheap in relation to its storage. So without those indication and relation, more in absolute values, I show you here this graph where all kinds of energy storages are displayed. And we have here on the horizontal, we have the energy density of energy storages, and on the vertical we have efficiencies of energy storages, and the area of those circles, they display the costs of storages. And electricity storage, so capacitors and coils, there we see a very large circle. So they are very efficient, but they're extremely expensive, so they are not really an option. Mostly discussed in all conferences, in all publications, are batteries, electrochemical storage. And you still see that the dots, the circles, are quite large, smaller than the pure electrical storage, but still quite expensive. When we again go to the mechanical storage, and especially when we look to the pumped hydro storages, that is the one that is applied nowadays most often, the dots become very, very small That means here the cost is low, but we see it also on the left corner. That means the energy density is also very low. That explains why those pumped hydro systems have extreme volumes of water. But the next step is even more attractive. When we go to the thermal energy storage, and especially to the very common hot water tanks, you even cannot see anymore these dots. That means storing hot water is extremely cheap. And then is one left, and that is the gas storage. And here the dots are even smaller than with the heat storage. And also energy densities are very high. Well, that's the reason why they are applied for the long-term storage. But to be honest, it's not the complete truth. It's just storing the gas, the conversion technology to produce from electricity and water, the hydrogen or then the methane is not included here. So that would increase the cost figure. But we could make the resume. We should use the cheap storages from the heating, gas and mobility sector in order to solve storage tasks in the electricity sector and not to store electricity just by itself. And then coming to the question where to realize this interlinking of the different sectors, interlinking electricity, heat, gas and mobility. We should do that there where the infrastructure already exists, or where energy and power densities allow to create such systems, such interlinks, and that is in our cities. There we have perfect prerequisites to do that. So having a look, electricity generation is done all over a country, all over the continent, and is interconnected via grids. Looking to a city, cities quite often are built on the side of rivers. And rivers nowadays are just used as a waste heat disposal of thermal power stations, but they also could be used as a heat source, maybe for a district heating grid. But of course, also cities have the electricity grid, but this is not an island grid. It is connected to the rest of a country's grid also. And then most cities are also connected to the natural gas infrastructure, and that's the reason why many CHP power stations are also built in cities or at the border of cities to supply cities with electricity. And what is now quite special here, the waste heat that cannot be used by a big power plant built somewhere in the green field, that can be used here in cities. So the waste heat is becoming a used heat, and it's distributed via district heating grids in the city to heat houses and industry processes. What else can we use for power generation in cities? And there photovoltaics is maybe the best option. Or with other words, I think we never will see a wind park within a city, and also a biogas plant is not very probable to see in a city center. But photovoltaics is ideally suited because they don't make noise, there are no movable parts, and the roofs of city buildings are ideally suitable for electricity generation by sun. Electric cars can be implemented in cities, electro bikes, and then we could use the heat of the rivers, using it via heat pumps that are electrically driven and also supply the district heating grid with heat. That, for example, already is done in our neighbor country in the Netherlands, here in Rotterdam, the vertical city. And here you see or you don't see a lot of pipes coming from the Rhine River supplying this vertical city in summer with cool or with cold to cool the building, and other buildings next to this building using the Rhine River water in order to supply it with heat via heat pumps in wintertime. And then when we add also thermal storage, that we have seen thermal storage is so incredibly cheap compared to electricity storage, we have the perfect flexibility in such a city. So when we assume there is no wind and no sun, and electricity prices will be very high in future, a city will operate its CHP power stations and gain a lot of money by selling electricity. When it's the opposite, when there's a lot of wind and a lot of sun, electricity prices will be almost zero, maybe even negative. And that means heat pumps can use this cost-free electricity to generate heat and supply to the district heating system. And whatever is too much is stored in the tank. And when the prices for electricity are in a medium range, it's not neither worth you operating the CHP and neither using the electricity in the heat pump, then the district heating is supplied via the heat storage. So a city is the winner by its flexibility that it is able to generate. Of course, we need also the communication network in order to control the complete system, and that means we interlink those grids for electricity, district heating, natural gas, mobility, and also communication. And that also is already done in Rotterdam, for example, with this so-called heat hub, a hot water storage in the city center. Some few words to the long-term storage. When we really go forward with the energy transition to renewable energy, we also will have some gaps lasting more than a week, maybe 2 or 3 weeks. And then all those technologies will fail. It's the batteries that are not useful, it's the heat storage that's not really useful. Then it's only chemical energy carriers that are capable to cover these enormous demands because of their high energy density. But power to gas, this technology is known to be very inefficient due to its high losses. But the high losses are heat losses. And when we build that on the green field, again, the heat losses are wasted. But when we implement it in cities, and especially when we then go to the power to gas technology producing methane, we have waste heat on a temperature level of around 200 degrees Celsius, and that's an ideal source for a district heating grid. So applying power to gas in a city infrastructure, it's not anymore inefficient, it is becoming a CHP technology. So that is implemented here. The power to gas couples the grid for electricity, district heating, and also natural gas. And then, for example, if somebody is not confident with electric car, also cars can be operated with natural gas, for example, for having a longer driving range. And now coming to a more local view of the speech, which is the best area in Germany suited to realize that. That is the state where they will have said, we have been the energy state #1 to the former usage of lignite, and today we are Germany's storage and flexibility backbone. Hopefully we'll do that. Why is that? Some data for North Rhine-Westphalia. In area, this state is only #4 in Germany. Lower Saxony, Bavaria, and Baden-Württemberg are larger. But by far, the highest population we have here in North Rhine-Westphalia with 17 million. #2 is Bavaria with 12, and Baden-Württemberg with 10 million people. And also, they have the highest population density apart from the city-states like Berlin and Hamburg. 29 of the 76 large cities in Germany are located here in North Rhine-Westphalia, and also we have by far the highest GDP. That means also here we have a strong industry that is able to shift electricity in time. We have already existing 225 district heating systems. Nowhere else that much can be found. And to give here some more detailed figure, a district heating grid we have in North Rhine-Westphalia with more than 4,700 kilometers. And that is followed by a small area like Berlin with 1,900 kilometers. And we have more than 100,000 customers connected to district heating systems. #2 is here Baden-Württemberg with only 36,000. So no other state is that suited to make this flexibility in our energy system when going for the energy transition than our state here, North Rhine-Westphalia. So the third hypothesis to be proven, thanks to lignite, North Rhine-Westphalia is energy state #1, and that will last forever. Hopefully not. North Rhine-Westphalia has the capability to remain energy state number 1 forever, even when we stop burning lignite, but only when it uses its unique prerequisite to interlink the different energy sectors and become the storage backbone. Some closing words. The conference IRES had been merging now with the energy storage here in Düsseldorf, and we also changed the location from Berlin to Düsseldorf. That is really hard for a professor coming from Cologne here. And so let me finish with a cultural contribution here from Cologne, from a music group called Parapluies, but that's only working in German. Über Köln lacht die Sonne, über Düsseldorf die ganze Welt. Thank you very much.